The following career visit presentation was zoomed in live to the College and Career Center on Thursday, April 21st, 2020.
All right, so we have another career visit. Welcome to Tracy Naso. Did I say that right?
You did.
All right, and she's going to talk to all of us about her career as a structural engineer, forensic architecture. What does all that mean? We hear engineering is kind of a broad area, but a lot of times there's a lot of really specific areas that even I don't always understand the difference between. So that's why we bring in the experts. So I'm going to turn it over to you, Tracy, and go from there.
Okay, great. Oh, Christopher, thank you. Hopefully I will answer all of those questions. If I don't, please let me know and we'll do it in the question answer at the end. Let's see. How are we advancing today? There we go. Okay, so a little bit about me. Again, my name is Tracy Naso. I've been working at WJE since about 2005. I started early that year. In that time, I've actually been in three of our offices. One is in Northbrook, which you guys may be familiar with, but just on the north side of Chicago. 2.5 years in our Honolulu office, coincidentally during the pandemic. So that was unintended, but it wasn't too shabby. And then now I'm working in our downtown Chicago office that's just down right next to City Hall. So in the middle of the loop. Presently, my title is associate principal and also unit manager. So when I moved back from Honolulu into the Chicago office, I took over managing that office. I'm a structural engineer. And my specialty is really in concrete structures and various types of concrete structures. We'll get into that in a few minutes, but really specializing in the investigation, analysis, and repair. I also do other materials, and I'll share that in a few. I'm from Western Kentucky, so I'm not originally from the Chicago area. I did my undergrad at University of Kentucky in Lexington. I got my bachelor's in civil engineering there. While I was an undergrad, I did a program called co-oping, where I did 3 alternating semesters between classwork and then actually working in an office. And that was with the U.S. Army Corps of Engineers in Louisville, Kentucky. And then I went on and got my master's in structural engineering from the University of Illinois at Urbana-Champaign and graduated from there in fall of 2004 and then went straight into work. So why structural engineering? It runs in my family. You know, a lot of people don't really know what engineering is, so we'll get to that. My dad's an engineer. I have an uncle an engineer. Now my brother's an engineer. So my poor mom, who's the only non-engineer, sometimes has some very interesting dinners that she has to sit through. But it caught my eye because I was interested in the problem solving aspect in it. And then I also loved some very unique structures. I was lucky enough to get to do a summer program or a couple of summer programs in high school that sort of did an introduction to this. And you see cool things like the Frank Gehry Walt Disney Concert Hall in LA on the left, some wild things like a suspended building where the whole thing is hanging from a central pedestal. And it kind of piqued my interest of there are these really cool ideas and engineers are the ones who make this happen. Originally, I was actually thinking about doing tall structures. I think that that's a pretty common career path for a lot of engineers and civil engineers. On the left is the Petronas Towers. When I was an undergrad, I think that was the tallest skyscrapers in the world at the time. It's since been superseded several times over. But 9/11 actually happened when I was in high school. I was a junior, which I think about where you guys are. It had a big impact in how I felt and thought about structural engineering, sort of the social responsibility involved there, limitations, and then what to do with it. So it kind of gave me a pause as I was heading into co-oping and then heading into grad school and sort of feeling out a little more of what do I really want to do? I was drawn to history and preservation. So you see these amazing Gothic cathedrals in the US, well, in Europe, and a few that are trying to do it in the US. They don't do a bad job. But also some engineering failures, which is scary, but very interesting. I will say it's a lot more of a head scratcher to figure out why something didn't go the way you thought it would than starting out following some codes and provisions in a book in the initial design. So that kind of got me thinking and looking at some other things and just designing really tall buildings. Nothing against the designers, but there are other things that are pretty engaging out there. So backing up 1.5 step, what is engineering? I went ahead and I went to the internet because that's what we do these days. And I actually liked dictionary.com's definition the best. Of engineering is the art or science, and I appreciate the art part, of making practical application of the knowledge of pure sciences such as physics or chemistry, as in the construction of engines, bridges, buildings, mines, ships, and chemical plants. And I think that summarizes it well. When I was, a junior, senior in high school, I really liked physics and calculus. It was pretty fun, but you reach this point where okay, do I just want to think about it all day, which there's something to that, or do I do something with it? So it's taking that theory and really applying it into real life. So then civil engineering specifically, this is from the American Society of Civil Engineers. Civil engineers design, build, and maintain the foundation for our modern society. Our buildings, roads, and bridges, drinking water and energy systems, seaports and airports, and the infrastructure for a cleaner environment, just to name a few. So that's kind of civil engineering in a nutshell. It's very day-to-day, our very palpable built environment. And then within civil engineering, there's several disciplines. So if you guys are starting to look at college curriculum, you'll see that even once you pick civil out of all of the different engineering practices available, you still haven't finished your decision making. There's still another choice to make. So structural is one of kind of 7, 8 larger topics. So environmental, hydraulic and hydrology, transportation, geotechnical, materials, construction engineering, and architectural engineering. I will say that as a structural engineer, I do get into geotechnical a little bit more in conversing, because that's how we get into foundations and the design of buildings once we get, follow the gravity all the way down to the earth. And then also materials and construction. Those are the ones that touch me. So there's a lot of interplay between these different disciplines. So kind of looking at some of these, we talk about from the ground up. I was mentioning foundations. That's where you start. So we've got different ways of doing that. A lot of these are driven by geotechnical engineers, and then structural engineers take it from once it kind of gets out of the soil. So on the left, some deep piles, on the right, left, concrete deep piles, and on the right, they're driving sheet piles. They're just chunks of steel. Eventually that ends up being buildings. So a couple of views under construction. You may recognize the guy on the left there. Bridges, there's a pedestrian bridge in Lake Forest on the left, and then a big highway segmental bridge getting constructed on the right. Tunnels, kind of something we don't think about all the time, but extraordinarily important. Cool things like stadiums. The one on the left, that is Miller Park up in Milwaukee. Sorry to admit, I'm not sure which one is under construction on the right. I think it's in Phoenix. Heavy civil comes into play, like dams, hydroelectric dams, power facilities, even the big towers that carry transmission lines. The structural engineer actually designs that. It's a specialty field. Some fun things. St. Louis Arch on the left, and then even the beam. This was actually one of Wisjani's projects. We had to figure out how to set that thing and support it without it punching through into the parking garage that's underneath. That's not on soil. And then more specialty structures, radio antenna, communications, shipyards, wharves, very heavy specialized objects. So a lot of times when you say, are you interested in going into engineering? What does that mean? A lot of times it's a basis of kind of interest in all of these: drawing, math, technology, science, problem solving is a big one, construction. But it really touches on all of these. So it's not just narrowly picking one. It's really an interest in all of these traits and commonalities that all play into engineering. That's one thing that I liked it. We get back to that practical application of concepts. So if you are interested, usually that looks like a science focus in high school, math, science, computers, if there's a CAD class offered. Sometimes there's even research positions available to high school students in coordination with local universities. In college, usually major in civil engineering. We always like to see participation in professional organizations. A lot of them have student chapters, and it's a great avenue to actually talk to somebody who's practicing in your field and get a better idea of, now that you're a couple years in a coursework, you sure that's what you want to do? But it's also a great opportunity through that, and then just in general, to do some sort of work option during college. Even if you're going to grad school, I found that extraordinarily valuable. It helped me really focus what I wanted to think about and do in grad school with kind of an end game insight. So even if you're thinking you're kind of heading in the realm of academia, I would still suggest getting some experience, during undergrad. And then for structural engineering specifically, we always like to see a graduate degree. You get a nice broad overview as part of your undergrad in civil engineering. You take a couple of structural design courses, but grad school is where you really get into the nitty-gritty of why things are the way they are and really start understanding those concepts so that you can apply it easier whenever you actually get out into practice. So most structural engineers will major in structural engineering. Internships are available in grad school also. Like with Janney, we actually hire most of our interns in the last year of their undergrad or when they're going into graduate school. And then consider research projects. That's how I got through grad school. I was working with a couple of professors in the lab, which was pretty cool. It's a nice way to get some hands-on experience. You have all these concepts that you're seeing in class, but breaking something big in the lab is really cool. You learn a lot from that. And then again, participate in professional organizations. So specifically, what does Janney do? We don't do traditional structural engineering. We work in the world of forensics and investigation. From our structural side, we diagnose why structures fail and we develop concepts for their repair. And then we do that by understanding what's going on. So typically when there's a failure, it means that whatever load demand happened to this piece of a structure, or even the whole thing, it did not have sufficient capacity, and we need to figure out why that is. So some of the work that we do, Hurricane Sandy, you may recall from a few years ago, some tremendous flooding and rainfall and just inundation that happened in the Northeast. Some of it was pretty dramatic on the front, especially heavy erosion. Earthquakes. This one's from Turkey. That's actually the very recently former manager of our San Francisco office, Ken Sasaki. He's still there. He just gets to do fun things again. We were on the scene after 9/11. We had some involvement directly in the collapse of the towers, but a lot of our work was actually assessing the damaged buildings around it. The two towers are the ones that you saw, but all of the buildings had some sort of damage, and somebody had to go in and take a look at that, even to the point of determining if it's safe for first response workers to even access the buildings. So sometimes people doing what I do actually got in there very first, which is scary and a good topic for another talk. We have failures like this. This is a truck hanging about 20 feet in the air because the slab that it was driving on failed, just fell out from underneath it. This driver was very lucky, and I'm glad I wasn't him. Hurricane Katrina. This was actually one of the first projects that I worked on when I started with Janney. I ended up going down to Gulfport, Mississippi, looking at partially collapsed structures. But we looked at wind assessment, partial damage, full damage, complete devastation. We looked at a lot of concrete pads that used to have a house on it. Thankfully, we were able to get some GPS units to confirm because there was no address anymore. Bridge collapses. This was a bridge under construction. The girder rolled, took the whole thing down. More construction accidents. Sometimes it's not all accidents and drama, like sometimes it's just maintenance. This is a limestone facade building. It just needs some love so that it can keep performing much longer than it started out. So we extend the life of structures. Same thing, we did a big project at Ryan Field in Northwestern University. Historic, the oldest parts I think are from, I want to say the 1920s, maybe 1940s. Plenty of use left in it, just needs a little love. kind of a cool project. After the earthquake in DC, I think it was about 10 years ago now, some of our staff actually rappelled down the Washington Monument to check for loose and shifted stones that had moved during the earthquake. Another view. Actually, that's Emma Cardini. She's the unit manager in our Boston office now. Another cool one, we got to rappel off of the St. Louis Arch. So it's made of stainless steel, but there was some weird staining on it. So we got retained to help figure out what and why and what do we do about it and if it's even important. Turns out it wasn't. But yeah, it's pretty cool. Just wrapping up a little more of what I do kind of day to day. This is sort of a little bit of the dramatic part. I mentioned looking at partially collapsed parking structures in Mississippi. That view on the left, that is me on the right, or on the left, I'm sorry. That's Brian Pulver on the right. A few years ago, but it was pretty cool. It's neat to see. You learn a lot about how things are put together by seeing how they fall down. On the right, that's a survey that we're doing in a utility tunnel in North Dakota. I work on a lot of different things. I do a lot of concrete, but I also work steel, aluminum, wood, masonry, glass, and occasionally a one-off fiberglass. I've gotten the pleasure of working in about 25 states across the US, and then with professional travel to 4 more, and then also Mexico and Puerto Rico. So I get around, it's pretty fun. A lot of times, like my typical project, we'll get a call and they're like, something's not behaving like it's supposed to, can you help us? This photo is actually from my very first project with Wisjani, where we had failures at the 5th floor of a 64-story building and a girder that was carrying one of those columns the rest of the way up the building. So it was a little challenging to figure out what went wrong and then developing a scheme to repair it. But usually we'll come in, we'll start with an assessment. For us, your eyeballs are actually your most important tool, eyeballs and brain. Go and take a look at it. A lot of times we have other resources like laboratory testing, load testing, non-destructive evaluation. We have a lot of tools at our disposal. One thing with WJE specifically, we actually have our own testing laboratory in our Northbrook campus. It's one of the largest, if not the largest private laboratory outside of universities. So that's pretty cool. So we'll go through, gather all that information, do an analysis, figure out what the demands were, what the capacity was or wasn't, and then we can develop a report to communicate our findings and recommendations. And that typically ends up going into some sort of repair design. So we'll develop repairs and specifications, and then construction. So it's kind of fun because I get to see it from the very, very beginning, and then I follow it all the way through, including working with the contractor and getting to see my design or my repair implemented and the finished product. So a few things that I've worked on recently. Humor me because these 3 are actually in Hawaii, so they look a little cooler than the typical Chicago fair. This is a historic monumental fountain, actually in the middle of a courthouse in downtown Honolulu. They were dumping water over it for about 30 years, and it just was not a very happy camper. One interesting thing about living on an island in the middle of the Pacific Ocean, you get a lot of salt from the ocean, and salt drives corrosion and reinforced concrete structures. So there's a lot of fighting of that. So they had actually stopped using the fountain as it was intended. You can see there's kind of some ugly staining. So our job was to figure out, one, if it was still okay, like, is that top part about to fall off the thing behind it? The answer is no. But also, what are the options for preserving it? It's a piece of art. There's a lot of interest in making sure that it can stay a piece of art in the public's area for many years and decades to come. So we were able to do a little bit of laboratory study of the concretes, look at the staining, look at the chloride levels, and then develop a few options for, in this case, the government, for how they want to treat it. Do they want to restore it to use? That would actually influence what the decision is. If they just want to look at it and keep it from falling on people, that's a different decision. So that was really fun to kind of work on something a little bit out of the ordinary and get to have some input on how we can keep it available for everybody to enjoy. I get to work on some older structures occasionally. These are always really fun. This particular one, we actually didn't get to work on the pretty facade space. We were working on the structure that held up the first floor, but also important. So we were evaluating concrete deterioration, figuring out, again, how bad it was, how serious it was, where were they along the curve, do we need to shore things? This case, no, we didn't. But we were able to evaluate it and figure out a plan for them to be able to prioritize. It is a nonprofit, it's the YWCA. So working with their budget over a number of years so that they can implement these repairs and continue use of the building safely. Some of them just have a really nice view. This is facade repairs on a resort. So a lot of concrete, lots of spot repairs, complete repainting. They actually finished up this work last summer and the building is beautiful. All new sliding glass doors on the balconies, all new guardrails. And then this was actually coordinated with a full gut rehab. So the whole thing is really, it's gorgeous. If you get to go out to Turtle Bay, it's pretty swank. And sometimes it's just a small piece of the puzzle, but it's an important one. So there's suspended ceiling tiles. So think of your suspended ceiling like you would, as I was saying, I should move the webcam, you can see the one above my head. Like you see in a regular room, except instead of 12 by 12 or 18 by 18 tiles, they're 8 feet by 8 feet. So there's giant metal tiles. And under certain winds, they were crushing 30 feet to the ground below, which is not a great situation. So we got to go in, investigate the conditions of the sports, found out that, when you have wind, there's sort of a, not fluttering effect, but there's downward pressure and there's also upward pressure on components. And when this system was installed in the 70s, it handled the downward pressures really well, but it had zero capacity for uplift. So what was happening is the wind was going by, pushing the panel up, it actually disengaged from its support, and that's why it was crashing to the ground. So we ended up rebuilding a whole nother support system for this. And this happens to be a landmark. So we were able to let people continue to safely be around that landmark. And a few other things, mentioned Hurricane Katrina. I've also done some roof collapses, some floor strengthening, a little underpinning, quite a bit of construction failure and troubleshooting. So some contractors in the middle of building a high rise, something didn't go right. We have to come in and figure out what happened. They're a little stressful because there's a very tight schedule, but they're fun because you get to be on a big construction project and be part of that. Like I worked on the Aqua building and that was going up downtown. And I get to say I had a little bit of a piece of getting that thing to where it was. Also do a little bit of expert witness work. You can probably imagine that when there's failures involved, sometimes attorneys also get involved. So we will come in and work on both sides of a case. It just kind of depends on where it goes. The work that I've done, it's kind of worked its way out of a regular project and it just kind of had one extra phase, which is not my favorite, but it's a thing. It's okay. And last time I talked to a group like this, I was asked to reiterate that I don't just do brainy stuff all day. We do fun things too. I like to hike, I like to run. I like outdoors clearly. And occasionally you get to go to a hot balloon festival in Albuquerque, or no, this was in Reno. Albuquerque also has one, which is highly recommended if anybody's able to travel. So it's kind of a high level. So what questions do you guys have?
Yeah, wow. So that was really interesting, at least to me. I seems like you got to go to really cool places. So try to find companies that work in Hawaii because there's a lot of stuff going on there, or by the ocean. Salt water messes stuff up. So there's gonna be jobs there. Do you guys have any questions? No?
How would you rate the working environment for a typical structural engineer, or at least in WJE, if you
Could you hear that?
I think I heard that, but can you repeat it?
How would you rate the working environment in a company like yours? Is that okay? Do you need clarification, or does that make sense?
Yeah. What if you don't mind?
What do you mean by?
I just mean I suppose your workplace atmosphere and I suppose your stress levels or your the relationship you have with your coworkers.
Okay, that I can get. I'm going to tackle kind of work environment first. I love my work environment. I have a fantastic team that I work with. I think with Shandy has been very successful over the years of just getting people that love what they do and they're excited about it. And there's nothing like coming to work and being in a collaborative environment where everybody is very supportive of each other. We're very adamant that we work as a team. It's not a lot of individuals fighting to get to the top. We're not set up that way. So that's really nice. On the stress side, it can be very stressful. I have definitely lost sleep when I've seen something that worries me, and I am concerned that I'm making the right decision. For better or for worse, instructional engineering, it's occasionally literally life or death. You know, you've seen some collapses with bridges where people die, and we can come in right behind that, figuring out why and how to prevent it from happening again. So it can be a little bit of stress there. Also deadlines. In consulting, we're juggling a lot of demands at one time. We've got internal demands, client demands. If you're on a construction site, very tight schedules with a lot of money behind it, which always gets people's attention. So it's high stress, but I find the work incredibly rewarding. I'm glad that I do it every single day.
Great, thanks. Any other questions?
Thank you.
Just really quick, so you kind of touched on some of the positives and the, maybe the downsides of the job. And you mentioned some of the skills, you might take some science, is there, like, what type of student or what type of person would be like successful in this? Is it somebody who's super strong in math? Is it they need more of the soft skills, or like who is somebody who would want to go into this this field, the structural engineering field specifically?
In structural engineering in general, a lot of it's problem solving and curiosity. So if you have that drive of like, I really can't let, like, it's bugging me. There's this question and I just can't let it go and I really need to figure it out. But also like the physicality of it, I once had, it was actually a presentation I was listening to, but the engineer who was giving it was talking about one day he's looking at a bicycle wheel. He's like, how's that work? Because why should it? You think about it, you have this wheel and you have little tiny fine spokes. Like those aren't carrying, the spokes aren't carrying the load. They're too skinny and narrow. And because I brought it up, the answer is it's actually all intention because of the way the load gets distributed in the wheel. But it's a good example of this kind of weird question of how does that work? And then you kind of dive into it and answer it. That's a very classic engineering mindset. Being talented in math and science makes it easier to get there, but hard work goes a long way. So that's what I like to tell people. As far as consulting specifically, I think there's a preconception that once you get into engineering, you never have to write a report again. That is entirely not true in my particular job. My work product's normally written, and it has to be written very well, especially considering the stakes and also if there's ever attorneys involved. So having those soft skills with being able to interact with clients and being able to interact with teams and collaborating and really defining problems, and then also explaining the options for resolving those problems. That's something that can be developed. But it is important, if you really hate talking to people, you can be an engineer all day. You may not want to go into consulting. It may not be for you. But that's the beauty also of engineering, is if you got that engineering mindset, there's a lot of different avenues of how to satisfy that.
Great, thanks. And if you have if you don't have a fear of heights, it sounds like there might be some options for you too, because some of those, like, I'm normally not that afraid of heights, but I don't know if I'd be, grappling from the side of arch or the Washington Monument.
I will tell. On YouTube, there's GoPro video of the guy that started out standing on top of the arch, flipping to the underside of the arch, and my blood pressure got up just from watching that GoPro video. And I will do swing stage work going down the side of a building, and like I think that's above my tolerance level. We also have plenty of jobs that don't involve getting on ropes, like ladders probably, but you can do a lot without going more than that. So don't let that hold you back.
Definitely good to know, I'm sure. If not that I plan to go into that career field at this point in my life, but for anyone here or watching, they know that they can keep their feet mostly on the ground and still do this job. So last call, anything else that we missed? If you'd like to know, they're shaking their heads no. You covered so much great info that that's pretty much the questions and the topics that we usually cover in these things. So Tracy, thank you so much for taking the time to share your career with us. And we really appreciate it.
You're very welcome. And then you guys have my email address. If anybody has any questions, please feel free to reach out directly, assuming that's okay with you.
Yeah, for sure. Will do.